Welcome to Convergence. My name's Mike Doran. I'm a California attorney. I don't have a dog in the hunt. You can look me up. State Bar number 147697. It's 112 here. And the Washburn fire, we're monitoring that. And today I want to talk about Albert Einstein. He said that among the most difficult problems in all of physics is the Earth's magnetic field. I believe it's the most difficult problem in all of biology. I like to monitor the null surface wind website. And strangely, when you move the toggle a little bit, it maps surface winds all over the Earth. And when you move it a little bit, it blurs the images, and you can see these undulations. These undulations, these sine waves, I believe are electrical. And I believe they link cycles like El Nino all the way to the antenna-like features of Antarctica and South America, among other places. And those undulations affect surface winds directly, and then ultimately affect the winds that allow warmer waters to come from the southeastern part of the Pacific and affect the El Nino cycle. That the whole cycle is related to electrics. But today we're going to start specifically on a study that came out and then became a news article or a magazine article in the National Geographic. It was published on August 19, 2019. It starts out by saying, it's entitled, Earth's Inner Core is Doing Something Weird. Data from old Soviet weapons tests are helping scientists get a high-resolution look inside our planet. On September 27, 1971, a nuclear bomb exploded on Russia's Novaya Zemlya Islands. The powerful blast sent waves rippling so deep inside the Earth, they ricocheted off the inner core, pinging an array of hundreds of mechanical ears some 4,000 miles away in the Montana wilderness. 3 years later, that array picked up a signal when a second bomb exploded at nearly the same spot. This pair of nuclear explosions was part of hundreds of tests detonated during the throes of the Cold War fervor. Now these records of these wiggles are making waves among geologists. They've helped scientists calculate one of the most precise estimates yet of how fast the planet's inner core is spinning. The article goes on to basically say that the inner core is roughly spinning about the same rate as the spin of the Earth. And it's a nearly frictionless liquid metal portion of the Earth that allows the inner core to kind of spin independently of the spin of the Earth. But the findings were inconsistent in that some found that there was a slight movement and some found that there was a greater movement. And ultimately, the scientists who are studying this, whether it was a super rotation, a slight super rotation, or a slightly faster rotation, a controversy has come up, even with very careful research, about precisely how fast the Earth is spinning. And at the end of the day, what these scientists have come up with is that this is This is really great data. Vidal, one of the researchers, recalls thinking, however, Yo's and other researchers' interpretation of the data didn't point towards superrotation and instead suggested something else seemed to be going on. Intrigued with the conundrum, Vidal, the researcher, went back to his data set on the nuclear explosions, but with the original analysis codes nowhere to be found, he had to start from scratch, digging even deeper into the Cold War ripples with an updated method. His resulting analysis still yielded superrotation, but it was both slower and more precise than previous estimates, pointing instead toward the newly described rate of 0.07 degrees a year between 1971 and 74. Yo and his college recently published an intriguing alternative explanation using data from twin earthquakes. Perhaps, they posit, the inner core is actually rotating at the same speed as the rest of the Earth, and the apparent difference could be instead explained by inner core having a jagged surface that shifts over time, with mountains rising or canyons cutting into the iron orb. While Vidal finds this analysis intriguing, but while he agrees that there may be more than superrotation in the mix, he's skeptical of Yo's explanation. One possibility, Richards argues, is that the blob itself is warping over time. That's like when you throw pizza up in the air. He says it's spinning, but it's flopping around, it's deforming as he rotates. It's also possible that the rate of the inner core rotation varies over time, says Axio Dong Sung, a deeper seismologist at the University of Illinois, who co-authored the 1996 study first documenting inner core rotation. Now, this is where I want to go with this. As you know, if you're driving a car that's electric, it can be, the motor itself can be attached to the battery so that when you brake it, you're actually charging the battery. And then when you accelerate using the same induction forces, you're using electrical energy. So what the data is starting to show is inconsistencies that is actually quite connected with the idea that electrical currents could either be slowing down or speeding up the core. And this is really consistent also with this idea of a dampening. Because a dampening, what would it do? Dampening probably would want to be consistent with what's going on with the sun. Because if the sun has got a minimum where there's higher cosmic rays or a maximum where there's less cosmic rays, you're going to have a changing electrical environment that the Earth is moving through. So it's not just the fact that the sun and the Earth get close at sometimes, or that all the things that the Milankovitch cycle talks about in terms of radiation, and then where lightning would occur, and where, I mean, there's a number of inputs, but also there is this idea that there's dampening. And so getting back to this idea of what we see now, and the name of the show is Convergence, this idea that technology is advancing very quickly, and it's taking some fields and putting them way up, and then those fields will converge with other fields and add an explanation. In this particular case, the null surface wind data shows that there are these undulations. And these undulations, where they're located, is consistent where colder water would be and colder oceans that are capable of holding more carbonation. So why is that important? Because when a surface lobe goes over highly carbonated ocean, the agitation and the lower pressure will remove that carbonation, get it up into the clouds, and then in the context of these electrical currents and fields, what it's going to do is it's going to alter the phase change rate from water to ice. And then that helps organize clouds. So because life is carbon-based, it starts to modulate in matter to where carbonation is. And it's a self-surviving kind of feature because the Earth's magnetic field, if it's too strong, it's going to capture too much atmosphere, and you're going to get haywire stuff that's contrary to life. If there's not enough of a magnetic field, then you're going to get Mars, and the atmosphere gets stripped away by the sun, and nothing lives. So from the very beginning, life has had to dampen this. And now there's evidence, strong evidence that this is so. And one of the strong evidence out there is these undulations that are stronger or more highly frequent in the more colder ocean areas, but also tropical storms themselves, which are, in my view, the most powerful capacitive coupling and lowest impedance place on Earth. You have what are called mesovortices inside. And decarbonation is going to occur at the most intense level there, even if in the tropics, the very warm tropical waters don't allow as much carbonation in the oceans. This is made up for by the fact that there's more agitation, there's lower pressure, and then in the wall cloud itself, you're going to get more removal of carbonation. And even though there's not as much, for instance, as much water vapor that's apparent in the eye of a tropical storm, that's where you're going to have the strongest decarbonation, and that's where you're going to see the strongest fields. And it's well known now that tropical storms that rapidly intensify, like Darby is today, it's up to 140 some miles an hour. It's a category 4 now. The electrical conditions were optimal. There was M-class X-ray events, which creates electrons. There is high cosmic ray, which is protons, and you're going to get and you have low solar winds or moderate solar winds that don't upset these static fields that organize over storms like Darby. What you see in the core are these mesovortices, which you see as organizations above and beyond just the eye. And you look at enough of these pictures of these eyes, and you see undulations inside the eye. Higher frequency undulations, which indicates how energetic they are. And you also see tremendous lightning with rapid intensification. That's been known for some time. But it's all connected ultimately, where you, even right now, you can look with your own eyes, you can go to null, you can see the undulations by the fire, by the Washburn fire in the Sierra Nevadas. You can see undulations along Baja, which again is acting like an antenna. You can see undulations lower frequency by Darby itself, and then as you go down to South America, in the Pacific Ocean, there's tremendous undulations. There's very strong undulations by Antarctica and South America, which acts as an antenna. Those connections ultimately lead, I believe, to these mathematical things that are just too stable and too much of an implausible complexity not to have an electrical association. So let me give you a couple examples of that. There's been coring in Ecuador, and the coring indicates in lake bed studies that El Nino has existed for about 5,000 years, and that its frequency is between 2.5 and 5 years. So what's interesting about those numbers? Well, the solar cycle is about 10 years. So 5-year frequency of El Nino would be once or twice every solar cycle. 2.5 years would be once in 4 times of the solar cycle. And then if you go back before that, 5,000 years, where the electrical configuration of the Earth would have been different. For instance, if there was ice in between South America and Antarctica, the Southern Ocean couldn't act like a common. So you have different electrical configurations over time, and from basically the Ice Age to 5,000 years, and in a slightly increasing way, El Ninos came every 17 years. When you say, what is 17 years? Well, that's, if you have 2 solar cycles, that means once approximately every 2 solar cycles. But again, you have this kind of a division of 4 going on. So you have these weird cycles that just, the stabilities that don't make any sense by way of just random wind motions. It's too stable for ambient wind, in my view, to do this. Even the El Ninos that we see now every 2 and 5 years. You know, a thunderstorm is something that it comes from daytime heating and then cooling instability, and it's done in 20 minutes. So that in and of itself is pretty random as it is, and for that then to equate eventually to an El Nino as a sum is just like throwing darts and going all over the dartboard. The fact that they've occurred over a period of time with this kind of a frequency is, in my view, an implausible complexity, and it can't be explained by ambient winds. It can be explained, however, by the acoustics of the Earth as it's attempting to dampen the signals from the sun and produce a consistent magnetic field that supports life. When it isn't doing that, it puts a lot of selective pressure on life to do just the opposite, to produce stabilities and to produce these kind of another way I guess I could explain it, if you had a jar of marbles and it had all kinds of different marbles, yet every time you went in and picked it, you picked out a green one. There's some hand in there picking out the other colored marbles and making it so that every time you pick that marble, it's green. That's kind of what an implausible complexity is. It suggests that other hand picking in there and taking out the other marbles. And the El Nino frequencies that we see, although it's never discussed, is just like that. It's an implausible complexity. And so now, as the technology is coming out there, where you can see these undulations on the null surface wind, and they're the same kind of undulations you see that a little bit higher frequency inside a tropical storm's eye, strongest tropical storm's eye, or that you see more consistently strong as you get towards the colder oceans, all indicate that carbonation, that CO2 effect, is from coming out of the oceans with surface lows where there's agitation, and then affecting the freeze rates of water to ice. There have been experiments in China, of all places, where they looked at acids, which CO2 becomes carbonic or carbolic acid, looked at weak acids. Of all things, it was research about cryogenics and what happens when you freeze a weak acid in a magnetic field with an anode and a cathode end, and what happens with water compared to weak acid is you get asymmetries of the crystal growth. The same thing happens with carbon dioxide. Same thing happens with RNA and DNA. You get these asymmetries. The only difference with RNA and DNA is that RNA is RN acid, DNA, DN acid, is in static fields will have different rates of freezing depending upon the size, shape, length, and the charge and the kind of the mirror characteristic of DNA. It can have charges one way or the other and be a mirror molecule. All those different characteristics will affect the freeze rates. And so nucleotides could be with early life both a model and a feedback. And that's where complexity arose. It didn't come from some random cell coming together by chance. It was all the nucleotides on Earth as a solution set becoming more complex to solve for the Earth's magnetic field and keep it dampened. CO2 became involved, and then the CO2 became symbiotic with nucleotides, because CO2 as well had this effect. As life became more complex and cells evolved, and just extra nucleotides in the ocean that got swept up with surface flows became a lot more rare. Then CO2's role became more pronounced and important, but by then, as cells evolved, the cells had an influence about the amount of carbonation that was in the ocean, and that's where we are now. So it's one of those things where CO2's role was part of with nucleotides, but now nucleotides in cells, part of their function is to produce carbonation in the oceans in such a way that it dampens or modulates Earth's magnetic field. Okay, thank you very much for watching. Please hit like. Please join the channel, and I appreciate comments if you have them. I'm trying to make the production a little better, but I'm just learning. There's a learning curve to this, but I think it's a lot of this stuff you could follow along as you're watching. You can go and get onto the null website, and you'll see the winds. Just toggle it a little bit and it blurs, and that's how you can see the undulations clear as a bell. That's just actually making it simpler for you to see the waves. There's no way these waves are produced by ambient winds. It requires too much speed of the factor that's creating them. And then you see if you go to the global lightning network out of the University of Washington, you'll see that the lightning strikes are always very close to where the undulations are. Another thing that's also consistent with this idea is, and it's really a huge comment on tropical storm forecasts, for instance. So in 2020, when we had this very, very active season, there was a record lightning bolt that went almost 700 miles, or is that kilometers? Anyway, almost across the entire north part of the Gulf. There was a long lightning strike, and that was on April 29th, 2020, indicating how active electrically the season was going to be. And that ties in perhaps to what the Earth's magnetic field is doing, the context of the solar minimum and high cosmic rays, the context of what humans are doing in terms of the dead zone and in terms of dams and fossil fuels that are being put into the atmosphere, taken out of the active biosphere and put into the inactive biosphere and put into the active biosphere. All these different things kind of coming together. And here we are in 2022, and the forecasters are saying, oh yeah, we're going to have an active season. There's a La Nina, which I believe does play a role in how currents flow, and then where capacitive couplings can occur more favorably. And yet It's the Eastern Pacific that's active, and so far anyway, it doesn't look like the Atlantic is nearly as active as the forecasters thought. So why is 2020 more active, or why was it like a record active year, and then thinking, hey, it's going to be active again, but it hasn't been, so far anyway. So I think it will behoove the meteorological community to understand that CO2 is important, but it's important in clouds in the context of electrical fields, that it's a dampened system, that that we're causing defects in these living feedback Earths that dampen or modulate the Earth's magnetic field, and that we better start taking some activities, or California is going to burn up, and ultimately it's going to lead to neoglacial storms, and then it won't be fun for anybody. Nobody will be arguing about taking water from here or there. Okay, I've talked myself out. Have a good day. Good luck. Thank you.